In problem 14.81, there's a suspended mass held by strings A and strings B, and it wants us to find the tension in each of those strings. The only thing we're given is the mass of the suspended ball. So if you want to just draw a free body diagram of that, you end up having always mg downwards, you got TA this way, and TB that way. You can divide it up as well if you'd like. You got TB cosine of 45, and then TB sine 45 for the vertical component. We can then make equations from this where the sum of the forces in the y direction is equal to TB sine of 45 minus the weight, and then the sum of the forces in the x direction is TB cosine of 45 minus TA, where these are both equal to 0 because it says at the beginning that there's no movement. So all you have to do is solve the system of equations. Do it in your calculator, or you can use substitution. We'll use this equation to find an expression for TB and then just solve it. So you have TA over cosine of 45 equals TB, and you can then just substitute that in to the other equation, and then everything will be titchy-poo. Okay, let's see. So TA sine of 45 times sine of 45 minus mg equals nil. So then, it's being annoying. How do you use this bloody thing? Well then, this so you end up with TA times tangent of 45 is equal to mg, and so there we go, that's better. So tan 45 times TA equals mg. We're looking for TA, so TA is equal to mg over tan 45. And then just plug in the numbers that you have for each of those. And then do the same thing with TB. You can actually probably just use this equation to solve for TB. The next part of the equation wants you to find what the tension in string B is immediately after you cut the string A. So the new free body diagram is now, ooh, it's red, okay, is now just that, actually. Except now it's acting like it's swinging, so you have a centripetal acceleration that way. So if you're going to write this equation out, in the solutions, they change the frame of reference. So this is now 45 degrees. So this component is equal to mg cosine of 45, and the other one's equal to mg sine of 45 here. And then you have your equations. So TB equal or minus mg cosine of 45 is equal to the sum of the forces, which is MAN, because it's swinging in a circle. So AN is equal to V squared over R. But remember that as soon as it's cut, it's going to start at 0 and then accelerate from there, so V squared is 0. So actually this whole term is nil. So what you end up with is just TB equals mg cosine of 45. And then you can plug in the numbers.